Dear students, this is first tutorial class on dielectrics. Here I will discuss some problems on dielectrics, different types of problem, so that you can be able to solve different types of problems. Let us discuss first problem 1. In this problem, it is mentioned that in a dielectric material, x component of electric field vector is given, polarization vector is given. You have to calculate these three parameters: susceptibility, dielectric susceptibility, electric field, and electric displacement vector, D vector. So there are three parameters to be calculated. So let us discuss one by one. So the first part, that is susceptibility. You know, this is the relation between polarization vector and electric field. So P equals to chi e susceptibility epsilon naught times C. So this is a relation, important relation. So from this relation we can write chi e equals to Px by epsilon naught Ex, x component of electric field. So in the given problem, electric field vector x, y and z components are given. We consider only on x component. So putting the value of x component only, after simplification, we have this result 2.16. This is the value of susceptibility. It is positive. Next one, electric field. From this relation, electric field can be calculated. Here it is x component of electric field, but when we will calculate electric field, then E vector, all the components should be included. So E vector equals to P vector by epsilon naught chi e. So putting the values of P vector, epsilon naught value and chi e, after simplification we will get this result 5 I cap minus 1.665 j cap plus 6.66 k cap. This is the value of electric field vector. Third one is the electric displacement vector. We have to calculate. So this is a well-known relation, D vector equals to epsilon naught E plus P. Putting the values of epsilon naught E and P vector, we'll get the values of D vector. After simplification, see the different stages of the simplification. After simplification, we have this result. This is the value of the electric displacement vector, where x, y and z components are given. The result is expressed in terms of picocoulomb per meter square. So this is our first problem. Now we consider second problem. So in the second problem, the relative dielectric constant of a material sulfur is given 3.75 at 27 degrees centigrade. Since the dielectric constant temperature dependent, that's why temperature should be mentioned. Density of sulfur is given 2.05 gram per cc at 27 degrees centigrade. Atomic weight of the sulfur is given. Estimate electronic polarizability of the sulfur. So to solve this problem, we'll start with the well-known Clausius-Mosutti relation. This is the Clausius-Mosutti relation. In number density, alpha is the electronic polarizability to be calculated, 3 epsilon naught, epsilon r minus 1 by epsilon r plus 2, relative permittivity or dielectric constant. So here, first of all, we have to calculate this n value. From Avogadro number, this is the relation. Atomic weight, this is the density. So n can be calculated from this relation, which is already calculated over here. So this is the Avogadro number. This is density, this is atomic weight, and adjusting the units, all are expressed in same unit. So finally we have the value of n is found to be 0.385 into 10 to the power 26. Putting this value of n, epsilon r and epsilon naught. In this expression, we have the value of alpha E equals to 32.98 10 to the power minus 38 farad meter square. So this is second type of problem. Third type of problem. So here in this problem, argon gas contains this number of atoms per unit volume per meter cube at 0 degree centigrade and 1 atmospheric pressure. You have to estimate the dielectric constant of argon at this temperature if the diameter of the argon is given. This is the diameter 3.84 angstrom. So here you will use this relation epsilon r, dielectric constant, equals to 1 plus 4 pi n into capital R cube. This is the essential relation for rare gas. Argon is a rare gas. R is the radius of the argon atom. So diameter is given, radius can be calculated. It is expressed in meter. So putting this value of R over here, we will calculate the value of epsilon r, and it is found to be 1.0024.